Hi everyone, my name is Josh Brenneman, and I work at the Institute of Genomic Medicine at Nationwide Children's Hospital here in Columbus, Ohio. Today my colleague Kyle Voytovich and I are going to talk about orchestrating serverless bioinformatics workflows with CDK, and more importantly how we use CDK to simplify the DevOps required for running our large-scale genomic pipelines in AWS. At IGM, we run different analyses on the genome. This includes identifying genetic variants in tumors and diagnosing rare diseases. We accomplish this by using three separate in-house services. On the top here, we have IGM Primary, which deals with sequencer information conversion, Churchill, our DNA analysis toolkit, and Varhouse, an annotation database for millions of variants that help our clinicians and researchers conduct their downstream interpretations. Today, we're just going to focus on the DevOps for Churchill. While developing Churchill infrastructure in AWS, we had a few goals. We wanted to redesign our pipelines as microservices and implement them as serverless applications. This would inherently mean that we would be able to scale our applications on demand and pay for what we use while moving away from our older monolithic design. We also wanted to provide an easy way to deploy containerized applications for our scientific developers. And many of our biological applications are versioned so that they can be run in a clinical setting or later reproduced for literature. So the question is, why did we use CDK? Well, we already had developers who could code in Python and JavaScript. The object-oriented design also allows us to develop reusable constructs for many diverse use cases and analyses in comparison to standard JSON and YAML. We can then write unit tests on our constructs and assert IAM permissions as well. We were able to deploy our versioned applications as CloudFormation stacks, which means that they can be easily deprecated or redeployed at will. We were able to utilize all these advantages of CDK to deploy different services for Churchill. We have a construct, the simple Churchill service, that has been written to support many of the cloud resources that run our containers or images in ECR serverlessly. An example of the simple Churchill service in action is setting up the resources for running compute-heavy batch jobs, like assembling the genome, like a puzzle, or managing hundreds of smaller to medium-sized jobs that calculate quality control metrics on the data in parallel. The simple Churchill service custom construct child class uses the AWS batch job definition construct to run an existing Docker image in ECR on managed compute environments, or Fargate. It creates Lambda functions via the AWS Lambda function construct to transform client input into Docker commands, and finally an AWS step function state machine or a CFN state machine construct to orchestrate the Lambda functions and batch jobs also in the stack. The state machine class depends on whether the definition is an Amazon States language JSON string or a native CDK iChainable child object. The CDK Python code is an intuitive extension over the Docker code, so our scientists also have an insight into how their pipelines are being orchestrated. Finally, we're able to use the object-oriented design and custom functions to build our constructs. For example, in the image on the slide, we wrote a class method that will render an Amazon States language formatted JSON file, which is written as a Jinja 2 template, Jinja 2, the Python library. Another example would be to supply logic for creating batch job definitions with either Fargate or EC2 compute using a Boolean flag. Using this architecture, we can now deploy all of our individual scientific pipelines to new stacks by using a simple command, CDK deploy. As you see in the image on the right, each of the bioinformatics services 1 and 2 have different stacks per version. Next, Kyle will cover how we put this all together.
Hi, this is Kyle. I'm going to give you an overview of the higher level resources that we use to coordinate the execution of the services that Josh talked about. As an overview, we have this large application that we call Churchill, which consists of many smaller services which perform alignment, bearing calling, QC, and more. In order to coordinate all these individual services and allow users to kick them off, we created a REST API. The REST API was created using the REST API construct, and users can submit JSON messages to the API in order to kick off Churchill executions. So on the top right of the screen, you can see the block of JSON with the list of services that the user wants to run, some input parameters, and a list of samples with data about those samples. The API then processes the request in a Lambda function and passes it to a global state machine, which then calls and coordinates the execution of the individual services. As you see here, users can kick off specific versions of the services that they want to run. So in this case, the user ran version 1.1 of Bioservice 1 and 2.0 of Bioservice 2. Allowing different users to kick off different versions through the same API endpoint supports two of our main use cases. So number one, we support the execution of validated pipelines on clinical hospital data. So we go through a validation process and we pick a set of versions, and then we want to lock those down so we can run the same software on our data to be consistent. Our other use case is that we want to support research applications where we update our services more rapidly and run the latest and greatest tools on our data. You can see in the diagram on the right side that our state machine also sends events to EventBridge during execution. So as new data becomes available when the service is complete, events are sent to EventBridge during the execution, and this allows our downstream service Varhouse to start and run its execution whenever the data it needs is available, regardless of whether or not the whole Churchill pipeline is complete. This leads to the next point. In the future, we're thinking of including an event-driven design for Churchill itself instead of this global state machine. So our scientists have created more and more services using this simple Churchill service construct, and we're up to about 7 right now, and there are more planned services to add to our pipeline. Because of the number of services, it's actually a little difficult to maintain the overall global state machine. So we're thinking of using a similar design as Varhouse, in which each service starts execution whenever data that it needs is available. So we'll track the metadata in a DynamoDB table and then send events through the services, and then downstream services can kick off whenever new data is available. We're hoping that this can help maintainability in this large application, but we're still in the early stages, so we're still exploring the idea more right now. Another future direction, we want to use CDK pipelines for our continuous integration and continuous development, because currently we have some in-house constructs to create those resources, code pipeline, code build, and so on, and it'll be more convenient once CDK pipelines gets a little more mature, so we're excited for that. Well, thanks for listening. If you have any questions about bioinformatics or about the CDK work that we're doing, I'm sure you can message us through Slack. Thanks.